Hi, in this video we're going to see an application question where we need to enact U-substitution. Now during this part of the course we've seen a lot of application questions where we're given a marginal quantity and we're asked to find the total quantity. Once again, we're in the situation where we've been given marginal revenue in dollars per items as a function of X, and then we're asked to find the total revenue function. Now keep in mind, when you integrate marginal revenue to get the total revenue function, you also need a point. You need an initial value that allows you to solve for C. Whenever the function in question is marginal revenue and total revenue, you need to know that the total revenue when you sell 0 items is equal to $0. That's kind of a common sense rule. So sometimes on this kind of question, they're not going to give you that information, and you just have to understand that the point R of 0 equals 0 is a point that we're going to use when we solve out for the plus C. Okay, so that's exactly what we're going to do. The only thing that's different between this and the previous examples is that it seems like we have a function of x inside of parentheses right here. So in order to complete this integral, we're going to have to use a u-substitution. Okay, nevertheless, the total revenue function will be given to us as the integral of the marginal revenue function dx. And so what we're seeking to do is integrate the marginal revenue. Now marginal revenue starts with minus 24 divided by some stuff. Anytime I see divided by, I'm going to go straight for rewriting that stuff on top with a negative power, just like that. And that's because I'm going to have to do that anyway to use the power rule, so I just get that out of the way. Okay, now I see that I have a function of x inside some parentheses, and that's a pretty good hint that you're probably going to want to use u-substitution, where your letter u is going to be the stuff inside the parentheses. Once you get the u in place, then you're going to take the derivative, and you're going to leave the du on one side, and the derivative of 2x is 2, and you're going to put the dx on the other side because you have a dx on that spot right there. Okay, actually, before I go into this any further, I'd like to make a note. The issue I'm having is with this term right here, right? Do I need a u-substitution to integrate the number 24? No, not really. So actually, before I begin, I would rather see this as two separate integrals. This one dx, where I need to use u-sub, and this one, the number 24 dx, where I don't need to use u-sub. Because I gotta be careful and make sure I don't overuse the u-substitution. I don't want to use it on something where it's not necessary. And you can see the number 24 right here. Well, that integrates directly. That's going to be equal to 24x plus c, right? So if you don't need u-substitution for a piece of an integral, go ahead and just shove that out of the integral and put that as a separate integral so that you don't have to accidentally use it on that, okay? So I'm just going to get rid of the extra 24. This part doesn't need a u-sub. This part very much does need a u-sub. So let me go ahead with that part and figure out where is my dx. Okay, so I got my u as 2x plus 6, du equals 2 dx. Do you see a 2 dx there? Well, I see a minus 24 dx. So maybe I want to multiply both sides of this equation by something so that I have a minus 24 dx. That sounds like a good plan. What would I multiply this whole thing by to turn the number 2 into the number minus 24? Probably minus 12 on both sides, right? Minus 12 would do that. So if I times by minus 12, I get minus 12 du equals minus 24 dx. Alright, that works out pretty good because I have minus 24 dx right there. And that underlined stuff is the stuff that I'm going to replace with whatever's on this side. So I'm going to replace that with minus 12 du. Okay, cool. So what's going to happen here is this part of the integral is going to turn into u to the minus 2 times minus 12 du. And then that part, I already did that part separate, so I'll just let that stay over there on the side. Alright, and so it looks like I just have a little bit of integrating to do here. If you like, you can pull out the minus 12 and just try to integrate the u to the minus 2. And once again, this stuff is just hanging out over here. That's going to just float all the way down to the answer, or sink all the way down. Now we have to integrate u to the minus 2. What does u to the minus 2 become? When you add 1 to minus 2 plus 1 makes minus 1, right? So that's going to be u to the minus 1 divided by minus 1. And there's still a minus 12 there. And so really that cancels with that. And so what I get is I get 12 u to the minus 1 plus 24x plus c. Oh, I'm almost there. I can see the light at the end of the tunnel. However, I don't like my situation right now because I'm trying to have my answer with u's in it and with x's in it. That's not right. I have to replace it so it's just all a function of x. I don't want any u's in my answer at all. After all, the question was posed as a function of x, right? Okay, so I have 12 u's, and that's the same thing as 12 2x plus 6 is to the minus 1 plus 24x plus c. I'm almost done. I'm not going to box it. I'll just squiggly line that because I'm very close to being done. However, I still have a plus c in the answer. And when the question is find the total revenue function, I want the actual total revenue function. I don't want a family of functions that are all vertical translations of each other. In other words, I want you to solve for the plus c. Okay? So now on this side, we're going to solve out for the plus c. But before we begin, would you guys like to check and make sure we're doing it right so far? That sounds like a good idea, right? Before it gets any worse. So here we have the statement that the marginal revenue is this function. So let's just check. Let's just take the dx of that stuff over there and make sure that it matches this marginal revenue function right here, okay? So up here, I'm going to check and make sure that this is the integral by taking the derivative of it. Let's see, if I take the derivative of that, the minus 1 comes down to multiply the 12, so I get a minus 12. Then I get 2x plus 6 to the minus 2, because minus 1 minus another 1 is minus 2. Don't forget the chain rule. You got to multiply by a 2 because the derivative of this inside function is 2 right here. Then separately, the 24x just becomes a 24, and the plus c just goes away to 0. And so if I rewrite that, minus 12 times 2 is minus 24. And if I want, I can put that quantity on the bottom to a positive power, plus 24. Hey, look, it's the same exact thing as what I was asked to integrate. Sweet. So I know I'm doing so far so good, and I definitely like to take a moment to check that before I go into the second part, which is solve for the plus c. Okay, so that part's all taken care of, and I've definitely checked that work. Now I just have to use the fact that r of 0 is equal to 0. Now in previous problems that you saw, you may have noticed when r of 0 was equal to 0, that led to c equals 0. Do not assume that that's always true. In fact, that's not going to be true usually when you have like some dividing by x going on over here. Because really what I have over here is I have 12 divided by 2x plus 6 to the first power plus 24x plus c, right? So I can't just assume that the c is equal to 0 because r of 0 is 0. I have to actually plug and chug here. I have to put the x equals 0 right there. Okay, and then I have to put the x equals 0 right there, and then I have to plus c, and that's supposed to be equal to 0. Alright, now what do I have on this side? Looks like I've got 12 divided by 6, so 12 over 6 is 2, and then this turns into 0, plus c is equal to 0. So what is the c actually equal to? Equal to minus 2, right? It's not equal to 0. It has to be equal to whatever's going to cancel out that 2 from that first term. So that leads me to c is equal to minus 2. And so finally, I can box my final answer with the c replaced with the minus 2. And that's going to be my total revenue function. Solved it.